All right. Well, welcome back. That's Jeremy. I'm still Christopher. This is Building Blocks Day 1 Initialize, comparing C#, JavaScript, and taking a look at how you do things in those cool environments. What we want to do is we want to take a look at classes, which is where we left off from the prior module, and then roll on into module 2 from here. Now, when it comes to software design, one of the biggest things that you're going to be looking to do is model your data. And the way that you're going to model your data is by creating classes. Now, when it comes to setting up classes in C#, what you're going to notice is that our classes are going to give us that ability to model our data, that the classic example of a blueprint is perfect, that what I'm going to do is say, this is what I'm going to want, and then eventually later on, I'm going to go ahead and instantiate that. Now, you are going to notice that inheritance is going to allow for a specialization, creating an is relationship. Now, when it comes to creating a class in C#, you're going to notice that we have a keyword called class. I want a class. I use the keyword class. And then I put whatever it is that I want inside of there. So you'll notice in my case, I've got a little customer, and then I've got a couple little properties there for their email and for their balance. Basic little class designed to model my customer. Then what you're going to notice down below is that I've got a brand new class that I'm going to call a corporate customer. Now, you're going to notice based on the name alone that obviously this is going to have some form of relationship with a regular customer. I'm creating a new type of customer. Now, because of the fact that my corporate customer is at the end of the day a customer, I'd like to get all of the different properties and methods from customer. This is where inheritance comes into play. Because corporate customer is notice the keywords there, that's the relationship that I'm creating, is a customer. So I can inherit from another class and create that specialized class. I can now create my corporate customer. So if we come back down to our slide, what you're going to notice is that I inherit from customer, and the syntax for doing that is by utilizing a colon. And so now my corporate customer will automatically get both the email as well as the balance from customer. That is our little inheritance in action. Now, one other little concept that I want to mention here, because you will see this quite a bit inside of the .NET framework, is a concept of an interface. And an interface creates a contract. Now, with an interface, you must implement all the methods and all the properties. Now, I want to highlight my change in terminology there, that you inherit from a class, you implement an interface. Because when I inherit from a class, that gives me stuff. When I implement an interface, that gives me chores. That gives me something that I have to do. I now have to implement that little method. So you are going to notice that down below, I would need to provide actual real live implementation for that do work method, which I just didn't do on the slide, but that is what I would need to do, is provide a full-blown implementation for that do work. Contracts are quite common in .NET when I'm looking to enhance functionality that's inside of .NET. Or if I'm looking to pass information from one environment to another, quite frequently I'm going to need an interface. The last little thing that I want to mention before getting in and doing my demo is simply the fact that when I inherit from a class, I can only inherit from one class, but I can implement as many interfaces as I would like. So let me fire up Visual Studio here, and let me open up my couple little classes here. So you're going to notice that I've got a class here called Member, and then I've got one called Platinum Member. Now, on Member, a couple of real quick things that I want you to notice is that, number one, I'm creating two little properties here called first name and last name. One I did automatically, and then the other one I did manually. So you'll notice that I've got the full-blown code right here. And this is what I was talking about having validation. Don't worry too much about the exact what's going on inside of there with my validation. The big thing that I want to highlight is just the fact that I can add in additional code. And then you're also going to notice if I scroll on down, then I've got a little toString method right here that will allow me to display that out. And you're going to notice that I'm using the .NET syntax for placeholders there for my string format. So 0 is going to be first, and then 1 is going to be second. So my last name will automatically slide into the second part, and my first name will slide into the first part. And I really should get rid of that comma. There we go. Then what you're going to notice is if I open up my Platinum member, that I'm going to add on a brand new property here called balance. So if we take a look at this real quickly in action, what you're going to notice is if I create, let's say, a Platinum member equals new, that on my member here, and let me just take advantage of the IntelliSense there, you're going to notice that we now get our first name and our last name. Now, if you remember from a couple of minutes ago, and let me go ahead and use Alt F12 there for the little code peek, one of my favorite little features inside of Visual Studio. I love that. What I want to highlight about our little Platinum member here is that the only thing that I put onto there was balance. But it inherited from member, and thus, as a result, it also got that first name and last name. So when I said my dot here, again, just using the IntelliSense, you're going to notice that there is my last name, and there is my first name right there. And that's my bit of inheritance in action. Now, as always, JavaScript does things a little differently than in C#.
Absolutely, it does. Let's go ahead and take a look at that. Okay, so when it comes to JavaScript classes and inheritance, first thing to note is that there aren't any and there isn't any.
Well, that's direct and to the point.
So you might wonder what we have to talk about here, right? Well, the need to implement a program in this fashion remains, and JavaScript just attacks the problem in a different way. Okay, so it's not a strong typed language. It's not a highly typed language, but we still need to have types. We still need to do these same functions, kind of an inheritance style of architecture, things like that.
You still need that encapsulation.
That's right.
Yeah.
So one of the things is if you're talking about, and normally we're not all that platform specific here, but if you're talking about the Windows 8 platform and developing apps using JavaScript in the Windows 8 platform, WinJS helps you out a lot. But there are a lot of different libraries for JavaScript that give you classes. They give you something that looks like classes. And there are patterns in the JavaScript library itself to implement the functionality of classes without actually using classes.
Yep.
Another thing to note is that TypeScript, which is a superset of JavaScript that's written by Microsoft, offers classes directly. Let's go ahead and jump out to the TypeScript homepage. You can feel free to go here at typescriptlang.org. And if you go to play, it's kind of cool. It gives you an environment where you can play with TypeScript and you can see the exact JavaScript that it's going to write. So if you look at a really basic bit of functionality here, you can see this is TypeScript, but it's not extending any of the TypeScript specific functionality. So when it maps over to JavaScript, it looks exactly the same.
Yep.
Identical.
I was looking for the difference.
Yeah, there are none. This is like one of those childhood games. You know, what's the difference between these two things? This one's a trick. There are none. Let's jump down and walk through classes and see what the syntax is that TypeScript gives you for classes. And look at that. All of a sudden, we've got a keyword called class. So we can create the greeter class, and then we can create a new greeter down here. And it's gonna work just like we would expect. But if we look over on the right at what's actually been done, it's implemented a class using plain old JavaScript. Okay. And the way that it's done that is by creating a function, and I'll show you how that works. Okay, so that's classes. There is a good sample for classes in TypeScript. And if you want to see how TypeScript handles inheritance, jump down to the simple inheritance demo, and you'll see how we've got an animal. A snake is a type of animal, but instead of a colon, we use the keyword extends. So snake extends animal, horse extends animal, and so on and so forth. So that's TypeScript. Now, one of the cool things I like about TypeScript is that TypeScript is using nomenclature that is looking forward to ECMAScript 6.
Okay.
So ECMAScript, the standard that JavaScript is based on, is going to have classes built into it. Your TypeScript uses the same syntax. So if you're writing TypeScript, you're really just preparing yourself to know ECMAScript 6.
So not a bad idea at all to start taking a look at TypeScript already.
Yeah, not a good idea. Not a bad idea at all.
A very good idea.
A very good idea, especially considering the fact that the TypeScript that you write is really just compiling to JavaScript, so you can always go look at it and see exactly what it's doing for you.
Excellent.
Okay, so that's like what we don't have, and then what we have as a not as a shim, but that we have as options.
Yeah.
But let's look really at what is it that JavaScript gives us core right out of the box.
Yep.
If we want to make something that's class-ish, we just class-ish. Yeah, that's my word. So we create a function or a variable, and in this case, I'm giving the variable an uppercase W. That's even a JavaScript convention here to say this is not just a regular old variable. This is a class. I'm going to make things out of this.
Okay.
And we simply set it equal to a function.
Interesting.
So that seems really weird.
Yes.
I remember that feeling very weird when I first came to JavaScript many years ago.
Yeah.
So what we end up then with is a function called called widget. And in order to instantiate that or turn it into an object like you do in C#, you simply use the new keyword on that function.
Okay.
And it gives you a new object where that function is the constructor of the object.
Okay.
So now I can instantiate a widget into W, a single letter variable. Causes consternation in some. So now I have W, which is an instance of a widget. Now, what about my properties and my methods? What about all my members of that class? Well, with JavaScript, we have this thing that some love, some hate. It's called duck typing. And duck typing is the fact that you can just throw properties onto objects anytime you want.
Yep.
It goes that if it looks like a duck and it acts like a duck, it's a duck, right? So we don't need to strong type this, turn it into an actual strong type duck. We can just say, well, if it's got a quack method, it's a duck. And anywhere we want to consume this class-ish thing, we can test and say, does it have a quack method? If so, if w.quack or if d.quack,
right,
then it is a duck. It looks like a duck. It acts like a duck. Now, if you want to shove properties into this class and you want them to be available for future instantiations of widget, not just for this one, then you need to put those methods into the prototype. And we're not going to go real deep into JavaScript prototypes. It's a relatively complex topic. Certainly don't have time for that. But anything you put into the prototype is available for future instantiations of that object.
And that's another topic that could take the rest of the day.
Absolutely. And we just won't.
Yeah. We have other cool things to talk about.
Absolutely.
Yep.
Okay, so I'm going to pass over this Win.js example here and move right out of classes and inheritance and move right into our next presentation.
All right. So with that, let me go ahead and fire up our little agenda slide here. And what do you say we take a look at lists?
Let's do it.
All right. So let me ask you a question. What are lists and why are they important? Why are they significant? Why
do they deserve their own module?
Exactly. You know,
Absolutely.
especially this early.
Yeah, lists end up being a very huge part of your workflow when you're creating an app.
Yep.
When you're creating your architecture, it seems to me that you're usually working with two fundamental things: entities or models, and lists of entities or models.
That's it. That really is it. And in fact, a lot of the concepts that we're going to learn, especially on the C# side, are going to be brought into our data store section as well. That when we go in, take a look at things like entity framework, what we're going to see is a lot of what we're going to learn here is directly applicable into that environment as well. So there's actually a lot that we're going to learn that's going to be important going forward. Now, you are going to notice back on my slide here that right over here, we have a whole series of different kind of breakdowns of all the different things that you could potentially do to a list and how you're going to do that in C# and in JavaScript. And stop me if you've heard this before, but it's, of course, a bit different. There is a lot of the same concepts that we still have the ability to perform similar operations inside of each, that you're going to notice that if I want to do ordering, I can do an order by utilizing link. There is still a sort method as well, but that winds up getting a little bit trickier depending on what you're doing. And then you're going to notice, of course, in JavaScript that we actually do have a sort. So basically, you're going to notice here that we've got a much better anything you can do, I can do as well. I don't necessarily want to say better here, but anything that you could do inside of .NET, essentially you could also do inside of JavaScript. Well, since I'm already talking, what do you say I just keep talking and let me roll right on into lists inside of C#. Now, in C#, our lists really break down into two main categories. We have arrays, and then we have these wrappers for arrays that are called collections. Now, with arrays, you are going to notice that our arrays are strongly typed, meaning that if I say I want an array of integers, that's all that's going to be allowed in there is just an array of integers. You're also going to notice that these are immutable, which means that they are not resizable. One very big thing to keep in mind for those of you maybe making the move from JavaScript into C#, strings are arrays. Strings are not immutable. So if you are doing anything to change a string, including, by the way, changing its case, but if you're trying to append onto it, every single time .NET's going to have to create a brand new string, and that's why we have the string builder class. So you do want to keep that in mind, that a string is an array of characters. It is immutable, meaning that we're not going to be able to resize that. Contrast that, however, with collections. Collections do still use an array behind the scenes, but they are optimized, they are geared to be resizable. So typically, you're going to find yourself using collections rather than arrays. In addition, with the magic of a little thing known as generics, which we're going to see in action here, we will be able to strongly type our arrays. So we will be able to, our collections. So we will be able to indicate right up front, hey, this is what I want you to be. Now, you'll notice that .NET gives us a lot of different collection types that are available to us. So right up at the very top here, you're going to notice that we've got the basic list, which is a single column, ordered list of items. We've got a dictionary, which is key value pairs. We've got stacks, which is going to be last in, first out. And then queues, which is going to be first in, first out. And all of these are kind of basic collections that you'll see in a lot of other environments as well. And if you go digging into the framework, you're going to notice that there's a whole host of other types of collections that are available as well. Now, the biggest thing that you're typically going to have to do with a collection is figure out what's inside of it. How do we actually get data out of it? How do we actually do all that little sorting? And this is where language integrated query, or LINQ, comes into play. Now, you'll notice that LINQ picks up the N from integrated, so that way we don't have to call it lick, which I think is kind of nice. And what LINQ is going to give us the ability to do is query collections and to create queries in the language that we're comfortable with. So if we kick over to my slide real quick here, the biggest couple of things that I want you to notice is that, number one, we have the ability to query our collections. And then number two, and this is what I was sort of referring to earlier, is that these can be translated into remote environments so that we can take LINQ queries and with some form of a facade in between, we can actually have them be translated into SQL queries, into SharePoint. I actually bumped across a link to Twitter implementation. So basically, you name it, and there's very likely going to be some way that you're going to be able to query that environment with LINQ. Now, the biggest thing that we want to know about LINQ is that it's made available by what are known as extension methods. So one of the things that Jeremy showed off just a couple of minutes ago was the ability to just take a property or take a method and just graph that right onto an object. Just boom, I now want you to have this. .NET actually has the exact same capability through extension methods. So it's not going to be as free form. Now, what I need to do is go in and create a class and say, okay, well, I would like this method, and this method to be available. And then the way that we're going to make sure that they're there is by making sure that we have the using statement that has the namespace for that particular class. And then .NET will basically take care of the rest from there. So we don't have the ability just to go ahead and graft it right on, but we still have the ability to make that available. Now, the other big thing that I want you to notice, coming back to the slide, is that all of our LINQ queries are going to be volatile, meaning that we need to actually capture the result if we are going to use this, and that all LINQ queries are going to use deferred execution. Now, if we take a look real quickly at an expression here, what you're going to notice is that this looks slightly familiar, that chances are you've seen that before. It looks...
Where was it?
Yeah, where was it? I swear to you, if I just did one little thing, if I just took this and I put that right up top...
And uppercased everything.
And uppercased everything, yes. That would look just like SQL. And that's sort of the goal. It is designed to be something familiar because SQL is a very natural way to query our items. Now, before anybody in the chat room says anything, because I know it's coming, you are going to notice here, yes, I wrote this slide, yes, this is mine, that I do use single variables here, but here only.
And what's different about here?
What's different about here is that, generally speaking, most of your queries are going to be relatively short. There's going to be just like 4 or 5 lines, and you're typically going to be looking for something to represent each object. So if we kick back to the slide here real quick, that let's imagine, and we'll see a demo of this in just a moment, that I had a collection of members. What I'm going to need, and this is, by the way, why from is up at the very top, what I'm going to need is something to represent each member. So just like when you're writing out a SQL query and you say select from, and then inside your from statement you say as, and then give it a single letter, you're only dealing with just a handful of lines there, and you're also going to find just over convention that you're going to know what the letter is representing. So here, I know that I'm dealing with members, so M sort of makes sense there. This is the only place that I'm okay with single letters. Everywhere else, I never use single letters. In any event, putting our single letter conversation to the side. The next big part that I want you to notice about this is right here that I'm writing out .NET code. So when I do my comparison, I'm always going to be doing this in .NET. Keep this in mind for when we get into doing the entity framework. That when we get into do the entity framework, what's going to happen is we're going to be querying SQL, but we're still going to be using .NET. And then last but not least, you're going to notice our little order by and our descending. And then finally, here's our select statement. And if you take a look right here, and let me see if I can sort of draw that out. There we go. If you take a look at my little rhombus, that what I've got, what I've got going on there is the exact same syntax that we saw before for creating an anonymous object. And this is extremely powerful, especially when I'm going to be talking about going to a backend data store, when I'm going to an OData service, because I want to just get back what I need. The ability for me to create this anonymous object on the fly gives me the capability to only request the data that I need. Now, if I fire up Visual Studio here, which I've got right over here. And let me just do a real quick close all but this. There we go. And there we go. Cool. So what I want you to notice is I've got a little list project over here. And then you're going to notice that I've got my little member class here. And this is just a basic little class with a first name and a last name. And then you're going to notice that I've got my little program right over here. And for right now, let me just go ahead and kill that. Let's take a look at my collection of members. And what you're going to notice is that I've got Christopher, I've got Jeremy, and I've got Stacy listed off there, creating all of that right there on the fly. And now I want to go in and query this. So let's say that I want to find everybody with, let's say, at least 7 names. Or 7 characters in their last name. So the way that I could do this is by saying var result, and I'm going to use var because I'm just going to let this kind of flow with me.
What about R?
R.
What about var R?
Var R.
Just an R.
No.
Just one letter?
No. All right, I'm done. From M in members. And let's go ahead and say where m.lastname.length is greater than 6, so at least 7. And then let's go ahead and just say select, and then we'll go ahead and just grab the full M there. And then what I could do is just down below, I can say for each, and let's say var member in result. And let's just go ahead and print that out with a console write line. There we go, and let's pass in our member. Now, the reason that I had that little toString there is that way I could just go ahead and call writeLine, and now it'll actually print out something meaningful. And so you're going to notice that when I run this, sure enough, there's Christopher, there's Stacy. We left Jeremy off because Jeremy's last name is too short. Sorry, man. And away we go from there. Now, let me do this. Let me come right down below this, and I'm going to say members, add, and let's say new member. And then let's go ahead and say first name equals Brian, and then last name equals Rothstein. There we go. Nice, real long name. And then let's just copy and paste our code here. So I'm just going to do that for each a second time. And let's take a look at what's going to happen here. And I want a real quick console write line and second execution. And let's put up here our first execution. Now, what I want you to notice here before I run my demo is that...
Second to first there.
Thank you. Just making sure you're paying attention.
Yeah, I was.
Excellent. Okay. So what I want you to notice is I declared my query here. Okay, just one time. I've got result here, and I've got result here. So I did not retype out my query. I did not tell it to re-execute or do anything. That what I did is I used the exact same result object. Now, when we take a look at the results here, what you're going to notice is, and let me just put a little line right about here so we can better see this, is there's the first execution, and just Stacy and myself. And then you're going to notice the second execution, and will you look at that, there's Brian. How in the world did Brian get in there? Well, the reason that Brian got in there is because of that deferred execution. That it waits until I use it to execute it. And if I use it a second time, it's going to execute a second time. And this is very important when you're going to be connecting back to a database. Because if I did something like this, and this is actually using a database behind the scenes, it's going to be 2 round trips back to that database, which is probably not what I want. Which begs the question, well, how do I then make sure that we're not going to round trip both times? How do I make my execution immediate? Well, the way that we do this is by using the collection. That if we kick back to our slide here, every time that we use that query, that's when it's going to get executed. Well, if I materialize this, let me just call a little method here called toList. That if I call toList, now what's going to happen is right then and there, it's going to create that list, execute that query. So this time what's going to happen is we're just going to notice the second execution will have only will have only myself and Stacy. It will not have Brian because we converted that to a list. So you do have to be very careful about that deferred execution because it's very easy to write some terrible database code if you're using LINQ. Okay, let me get back to my slides here. There we go. And I want that and that. Okay, now, as it turns out, that's actually the easy way to go in and create our queries. The slightly more advanced way, although much less verbose, is to use the methods that LINQ is actually using behind the scenes. So when I said select, it was actually using select. When I said where, it was using where. When I said order by, it was using, well, I'll let you figure that one out on your own. So it's order by, just saying. But in any event, behind the scenes, it was actually using those methods. Well, as it turns out, we can call those methods directly as well. And that can be very helpful when we're looking for something that's going to be very simple, very easy, that maybe we just don't feel like typing out the 3-4 lines of LINQ code just to go in and grab. Now, the couple little components that we need to keep in mind if we take a look at my slide here is that, number one, we're going to pass in a Lambda statement. And that's going to indicate the particular query or maybe property that we want it to act upon. Now, we are going to see our Lambda statements in just a moment, but one of the little things that I want to mention is that when you're new to this, those Lambda statements can be a little bit intimidating. And if you're interested in a lot more behind-the-scenes information about kind of how we got from where we once were to now where we are, is I do have a bit of a shameless plug up here on the screen. I did write up a blog post that walks you through kind of everything from start to finish on how we got from just a very basic little sort method method all the way up to using these little lambda statements. So kind of walk you through the whole thing. And then you'll also notice that the method indicates the operation. Now, the difference here between all of these, I'm going to do that again. The different methods that we have available are way too numerous to list, but there are a couple that are worth highlighting here that I find myself reaching for rather than going off and doing the link query. So you're going to notice that we've got single or default, and then first or default. And then with single, what that's going to do is give us back one item. But if multiple items match the query that we provide, it'll throw an exception. In the case of first, it'll give us back the very first item, so there could be multiple. The or defaults would give us back typically a null value, but in the case of like an integer, it would give us back a 0 if it was not able to find one. So if maybe I did a search based on an ID, that ID exists, it would give me back the object. If it doesn't exist, then it would give me back the null value with my or default in there. You're also going to notice that we've got any and all. What any allows me to do is check to see that one item matches something, as opposed to all, which is going to check to see that all items match some particular criteria. And in particular with any, this is going to be faster because all that .NET needs to do is look to see whether or not one item matches that particular criteria, as opposed to looking at all of them. Now let's go in and take a real quick look here at an extension method. And what I'm going to do is let me just real quick refactor that out, extract method, and this is going to be my link syntax. There we go. And let's go ahead and sort of do the exact same thing that we had before, but this time we'll do it with our link syntax. So what I'm going to do is say var result equals members where. And so I can just type out my little where. Now you'll notice that, let me see if I can do that a little bit faster. .where, there we go. What you're going to notice on the icon is that it's got that little down arrow. That's what's telling us that it's an extension method. So if you don't see this, the reason is that you're missing a using statement. So make sure that you have that using statement. Fortunately, most of the different templates in Visual Studio will automatically put that in there, but just in case it's not there. So it's going to be where. Then you're going to notice that, again, what I'm looking for is for that last name. So I'm going to declare that M right on the fly here. And I'm going to say greater than 6, just like before. So just to do a real quick compare and contrast, there's my M declaration. There's my M declaration. There is my little condition. There is my little condition. So it's the exact same thing, just done up with a different bit of syntax that here in the middle, I just have that little breakpoint, that little pointer, that little happy face, if you will. Always looks like a happy face to me. But in any event, especially when you put a circle around it. But in any event, that is going to be a little bit less code for me to go in and write, and I find quite frequently is actually easier to read in the long run. So if I just copy and paste my little for each, just like that, now I go ahead and I run this, and sure enough, you're going to notice that there is my little result again with myself and Stacy, and I've got the little typo in there about the comma, but I'm not going to worry too much about that. Now, this, of course, is different in JavaScript.
It is. It's quite different. And let's look at that now.
Yes.
Now, I'll tell you what. I did this shift from C# to JavaScript some time ago. And after being in the JavaScript world for some time, you know what I said? I want to go home. I want to go back to C#. And one of the main reasons was the link methods. Yep. Oh, I missed those so bad. Yep. Until I learned that there are a lot of other ways to get that kind of functionality in JavaScript. So it's different, but it's there. And I'll kind of show you how you're going to map those link skills into the JavaScript world. So I'm going to do all of this through a CodePen. So go with me now to CodePen. You can see the URL. And the way I have this set up, I basically am just going to be looking at the JavaScript. So I'm going to go ahead and hide the other two panels. And in the JavaScript panel here, I have some outputs. What does output mean? That's not built into JavaScript. That's my own function down below. And all that does is take whatever I want and drop it into the pane down below so I can actually show you some things. So that's what output means. And here's what we're outputting. Now I'm going to set it up with an array called A. What is it that makes that an array? It's just the square braces. That's it. The square braces mean that whatever is inside of here is a collection of objects or an array of objects.
Okay.
In C# we have lists and enumerables, and we have the IEnumerable and IList as the interfaces for these objects. We have collections and hashes and dictionaries and all kinds of different strongly typed ways to store collections of information. And they're all super great, and I love the way that works. In JavaScript, basically, we just have arrays. And they're all dynamic, and we don't need to differentiate between them because they're just kind of all dynamic and they can all cover most of those use cases.
Right.
Now, they don't have as much specialization as, for instance, a dictionary, but it's easy to get that functionality in a dynamic fashion. Here, I'm just using a plain old array, and I'm putting 5 numbers inside of that array. 2, 1, 3, 4, 5, purposefully scattered or randomized.
Okay.
All right, so let's look at the first array function. Now, the array functions are kind of JavaScript's way of replacing LINQ.
Yep.
Replacing the functionality that LINQ gives us. That is, functions on lists. Because the way I see it, we have entities in our application. Like I have a person object, and I'm able to hang methods on that person object and determine some behavior of that entity. But then I have a list of persons called people, perhaps. Now, what's the functionality of people? Well, I don't really have an entity that I can hold on to, or I don't want to go through the work or abstraction of creating a people object to put my person objects in. And so instead, I can just use LINQ, or I can create my own extension methods that allow me to do things to that list of persons.
Right.
So that's the fundamental thing that we're trying to do. So JavaScript's answer is array functions, and it covers a few of the LINQ cases, but not all of them. Okay, so I'm going to show you a few of the cases that it will cover, but then I'm going to lead you into some libraries and stuff that will cover all the cases. Now, by the way, don't be intimidated by the awesomeness of the LINQ methods, because as awesome as they are, they're often not all that complicated inside. And if you go look at the disassembly of a LINQ method, you go, oh, wow, I could have written that in an hour. That's awesome. Some of them are going to have some optimizations that are probably written by a person with more degrees than Fahrenheit that I wouldn't be able to aspire to. But for the most part, they're all pretty simple. And so when you find something like a distinct and you go, oh, we don't have that in array functions, just write it. Nice and easy. Then you always have it. Okay, so the first one we're going to look at is sort. Sort is analogous to order by in the C# LINQ methods. Okay, and in this case, I'm showing you sort right here without using any... I'm not passing in anything to it. I'm just using sort all by itself. And that is hanging directly off of A. So it is hanging off of something that is an array. And so this is valid. It works. And as you can see, it actually has the effect that I'm interested in. It looks at numbers and says, yeah, I know how to compare numbers to each other. So I'll sort those for you. And it puts them in order. Now, I'm not going to show it, but do keep in mind that you are able to pass in a function here that receives 2 values, and inside here you can compare those values, and essentially all you need to do is return either -1, 0, or 1 to determine which order these should be sorted in. Okay.
Is
it that A dot value is less than B dot value, or is it A dot first character comes alphanumerically before B dot first character? How do you organize these two things? How do you compare them to each other?
And so just like in .NET, where you've got the compare or compare to, that it's that exact same thing, that -1, 0, and 1. Okay.
And obviously in .NET, if you're comparing a couple of numbers, .NET says, I know how to do that for you.
Right.
But if you're comparing a couple of widgets, it says, I don't know which is the greater widget.
Right. Yep.
That was just fun to say. Let's move on to the next one. And in this one, I am actually using a function. Now, I want to do another little language construct mapping for you here, and that is right here. This is an anonymous function. Remember I talked about them earlier?
Yep.
This is used directly in place of a lambda statement. Okay. So we don't have lambdas in JavaScript, at least not in ECMAScript 5. We have them in TypeScript, which is cool. But in JavaScript, as it stands now, we don't have Lambda statements. We have the same exact functionality, but it's longer. It's not as fun to type function, paren, mustache, as it is to just type the happy face, right? Kind of the evil happy face.
Okay. All right. Yeah. Yeah.
It's a bit, yeah. But it's the same functionality. So what we're doing here is we're calling map. Now, what is map? Map is an obscure term, in my opinion. I like select better, the way it's called in C#. But, it actually does indicate, maybe even a little bit more so, what this is doing. What these are projection methods. They're taking whatever it is that you have in your list and turning it into something else. Each of those individual items. What do I have in my list? I have numbers, right? I want to map those. I want to turn them into something else. And it could be a really complex projection. In other words, I want to take numbers and instantiate an object based on that number. That's a relatively robust projection. I'm doing something completely different with the objects in my list.
Yep.
In this case, my projection is really simple. I want to take those numbers and just add 1 to them. So I'm kind of transforming my list one element at a time by applying a function to those elements. So here in my lambda function, in my anonymous function, I'm receiving a parameter. I'm saying this is going to represent the item in my list. And I'm going to use a single letter variable. And so this item is available to me now inside. Do you see what you started?
I do see what I started.
It's available to me inside of my function, and I'm able to return I plus 1, and it's going to map those to whatever they are plus 1. So now 2, 1, 3, 4, 5 has become 3, 2, 4, 5, 6.
Okay.
Taking note of the fact that the sort function is non-volatile. Meaning that I did a sort function on my array, right? Did it change my array?
No.
No. My first result printed out, my appropriate, sorry, I'm scrolled down here on accident. Why isn't my sorting working? Oh, it's because I goofed it up. I added this function, and I forgot that CodePen is evaluating things all the time. It's always watching. It's always watching. Okay, so there's my vanilla sort, and my sort actually works, but it doesn't change the array.
Right.
So now when I go to map my array, it's back to the original array. Excuse me. Now, some of the array functions are volatile, and some aren't. That will bite you. You just have to be aware and recognize when it happens, okay? So this is the map function. It has mapped and added 1 to each. Now let's look at the next one. I'm going to look at the filter function. This is analogous to which one, Christopher? Filter equals...
Where?
Filter, right here. No, I'm kidding. Filter equals where. That's exactly right. Thank you.
Thank you for setting me up for that.
Christopher on the spot shines once more. So filter, I am going to need to give it a function, because if I just say filter, that's kind of meaningless, right?
Yep.
Where nothing is just going to return everything that does nothing. So I'm going to pass in a function and say, how do I want to filter the items in this array? I need to do a test on each of the items. So whereas with my mapping, I can return whatever in the world I want, and that becomes the new value. With my filter, I need to return something that evaluates to true or false, just like the lambda statement in the where clause in LINQ in C#. I need to return I, in this case, I is greater than 3. I only want the values where I is greater than 3. It filters my list, and so you can see that in my filter, it's only returned 4 and 5. Now, you can do chaining, which is excellent, because the array functions themselves return arrays, so they're easy to chain on one on top of another. So I can start with A, and then I like to, whenever I'm chaining, drop down and indent so it's clear. And in this case, I want to map everything and increase it by 5%. Maybe I'm working with stock quotes, and I just want to pad my numbers there, increase everything by 5%, and then return the ones that are greater than 2.5. And there we go. I've chained those together, and I've got myself a nice result with a really ugly float conversion there. looks pretty slick. It's very accurate.
Yes.
So that's that. Now, do keep in mind that with arrays in JavaScript, because we have functions that are kind of first-class citizens and able to be passed around dynamically more easily than in C#, it's possible, and in fact somewhat common, to create an array of functions.
Yep.
So that just kind of makes your mind go. But an array of functions is something that then we could iterate and do something on. So here I have an array of things, of objects, anonymous objects that have a name and then they have an action. And I could then write something after this that says something like operations. This is an array, right?
Yep.
Operations dot for each. What do I want to do to each of the elements in that operation? Well, I'm going to write a function, and I'm going to receive the value, and I'll go ahead and put whatever it is I want to do in there inside of this block. So what do I want to do to each? Let's say I want to find the one that has the name of addition, and I want to execute its function. Well, once I've found the one, I would add a filter function or a single or something like that to get that one, but for now I'm just going to assume I have it. I can then just do a action and use the parentheses. Remember I told you that there's a difference between specifying a function like this, which just refers to it, versus like this, which executes it. I have now executed the action. In this case, I'm executing all 4 of those actions. But if I just wanted to execute one, I would simply do a filter first, and then I would execute the action.
Oh, nice.
Yeah, so you can do real fun dynamic things like that in JavaScript.
Well, we can sort of, in JavaScript, I can sort of do something like that. I mean, I could do a lot of those different things.
Prove it.
Wow. All right, then. So one of the things that you could do is you could go in and find those types of methods dynamically. I will admit that in .NET it does take a little bit more work, that you'd have to go in through reflection, find the item that you want. But there is a cool little extension method, or I should say method that's available because it's technically not an extension method, but a method that's available on collections called for each. And if we kick back over to Visual Studio here, what you're going to notice is that I've sort of got where we left off here. And let's say that, this was some really long block of code here. Now, whenever you've got a long block of code, one of the things that you want to do is to create a method. Because by creating a method, now I get to name it. That one of the terms that Jeremy brought up earlier that I'm going to reuse here is a term called code smell, which comes from a book called Refactoring, Improving the Design of Existing Code, which was Martin Fowler, I think it was Kent Beck, and some third author.
Better have those right now that you've mentioned them.
Yeah. I know for a fact Martin Fowler was on there, and I want to say it was Kent Beck, and then there was a third person. Somebody will go off and find it momentarily, I'm sure. But in the meantime, one of the things they talk about is code smells. Little things that aren't necessarily wrong, but could be an indication that something is wrong. And so whenever you've got a long block and you haven't described what it is that it's about to do, or maybe you've described it with a comment, yes, comments are code smells, then what we'd want to do is create a little function. So what I could do is just simply right-click, refactor, extract method, and let's say display member, just like that. And so it will create that down below. And I could leave that as just the for each the way that it is. But now I've got 3 lines, or potentially maybe the way that I had it written before, 2 lines of code to go off and do that. And that's not necessarily the cleanest way to go off and do things. So fortunately, what we could actually do instead is this, is I could just simply say result, and I could say for each, and I could say display member, and then just pass it in. Now, if you remember back to something that Jeremy talked about before, parentheses mean that you're calling it, same concept here. That if I said display member and I put in parentheses, I'm trying to call it. But what I'm trying to do is say for every single member that you find, take that member, pass that into display member, and then poof, now you're going to notice that there's my result again, and now it's down to 1 line. You're also going to notice, let me go ahead and just comment that out one more time, that I could even just build the method on the fly here. So I could go in and say result, and then for each. Now, I know that we're going to be talking about members. So if I declared a variable here, we'll call it m. Yes, I would actually call it m here. I can then use my little evil happy face, and then I could go ahead and define what it is that I want. So I could go ahead and just simply say console write line right here, member, or m rather, that's what I used. There we go. And now that's going to be the method that would be called each time. And if I actually just fired up the debugger here real quick, what you're going to notice is that if I hit F11, put my mouse over M, you're going to notice the first time through that it's Christopher. And, oops, let me F5. That wasn't quite what I wanted to have happen.
You could put the breakpoint inside the lambda. Do you know how to do that? If you click inside the lambda and hit F9, that'll take your breakpoint away. And then, click F9 again, and it'll put the breakpoint inside. There you go.
There we go. Okay. And now, let me F5. Okay, so now what you're going to notice, there is Christopher, and then we'll do an F5 again, and now you're going to notice that there's Stacy. So it is just doing that right there on the fly for me, and can certainly be a much easier, much cleaner way of going in and creating your code.
And I know you can also, as opposed to just looking for the places where it already accepts an action and you can pass it a lambda, or having to write your own strongly typed delegates, you can also define functions and such that they receive actions, right? So that then that's kind of like a very generic delegate, right?
Yeah, that you could go in and actually create a function that accepts that as a parameter, accepts the action as a parameter.
Yeah. And there's actions which don't return anything, and there's funcs, which return something, function, right?
Yep, absolutely.
Excellent. Well, have we covered entirely the topic of lists in C# and JavaScript?
I think we did a pretty decent job of it.
Yeah, I think there's probably a few more things to know about them than what we were able to cover in 50 minutes.
Absolutely.
Or less.
Yep.
But I think we'll have to go ahead and wrap this up. Wrap this topic up for here. Now, there was one thing I wanted to mention and forgot to, and that was that, remember I told you that in JavaScript we don't have all of the link stuff, but there are some array functions that do give us some functionality there.
Yep.
And then I told you that there are libraries that will give this to you. One of those libraries is underscore. Underscore is a great one that gives you a whole bunch of the link-ish functionality built right in. So if it exists in underscore, there's no reason not to take that dependency and use that instead of rewriting it yourself. There's also a library, I believe it's on Codeplex, called link.js that attempts to use the same link syntax and basically just port that directly over to JS. And I noticed that the author hasn't been maintaining that lately. I'm not sure if it's going forward or not or what, but use that at your own risk, fork it and extend it, whatever you want to do.
There you go.
You can do it all.
Yep. Hey,
Okay, so that covers lists.
Yep.
And the next thing that we're going to be looking at is the topic of asynchrony and concurrency. So kind of a large, hairy topic that we're going to make perfectly simple, elegant, and understandable to you.
With a little bit of luck, but before we do that, we're gonna take 10 minutes. Yeah, let's do that.
Let's go ahead and take a break.
Yeah, so we'll see you guys back here in 10 minutes.